Hello, student. The question says a parallel plate capacitor has a uniform electric field D in the space between the plates. If the distance between the plates is D and A and area of each plate is A, the energy stored in the capacitor is. We already know what is the energy stored in the capacitor. Energy stored in the capacitor is half C into V square. Then C would be epsilon naught A by D into V square. But the other doesn't want in terms of V, the other wants in terms of electric field. We know in a parallel plate capacitor, the electric field is uniform. And the electric field is uniform. And V is basically the voltage, which is potential difference between the two plates. So if you want V could be written as electric field into distance D. This is only valid if the electric field is uniform. So in place of this, I can write half epsilon naught A by D. In place of potential difference, that is voltage between them, E square into D square. So this D and this D would get cancelled out. So we'll get energy is equals to half epsilon naught A E square into D. So we can also write it as half epsilon naught E square into A into D. So the correct answer for this would be half epsilon naught E square A into D. But there is one more very important thing that you have to gain from this problem. That is, what is the energy stored per unit volume? Energy stored per unit volume. This generally we indicate with small u, which would be energy divided by unit volume is, what is the volume here? The volume of space that is present is, you can think that if I take the plates and the distance between them is d, it looks like an imaginary cube. Since it's an imaginary cube or cuboid, the volume here would be the cross-section area A into the distance between the plates. So basically E by AD, it would be half epsilon naught into E square. This is a very important value. In our syllabus, generally, if you take any topic in our syllabus, the energy stored per unit volume, I mean electric energy, like energy stored per unit volume, wherever electric field is involved. Most of the time, the electric field where these such questions are asked would be uniform electric fields. It would be half epsilon E square, of epsilon naught into E square if it is vacuum, or else it is half epsilon E square. Similarly, the same thing we can write for magnetic field as B square by 2 mu. So this is the energy stored in magnetic field. This is the energy stored in electric field. If you know this, you can actually get the other results very, very easily. Since if you already know this beforehand, if you want the energy stored per unit volume in capacitors. So similarly, energy stored in capacitor would be energy stored in capacitor. We know that the energy stored in a capacitor, here the electric field is uniform. So we'll write half epsilon naught E square into volume. So simply half epsilon naught E square into volume would be AD. In one step we can do. We can further extend it. Similarly, if they ask you what is the energy stored in inductor, energy stored in inductor. So inductor is a solenoid, and you should know that the magnetic field in a solenoid is mu into Ni. Right now I'll go for a vacuum, so it would become mu naught into N into I. So energy stored in a solenoid would be half B square by mu naught into volume. What is the volume of this? If L is the length of the solenoid, assume that L would be the length of the solenoid. So the volume that this is occupying would be like a cylinder. Since it looks like a cylinder, it is cross-section area into length L. What will be the cross-section? Then I can further write it as half. B value can be written as mu naught square N square I square into AL divided by mu naught. So I can cancel these two. So the energy stored in an inductor, which is also like due to self-inductance, is half mu naught N square AL into I square. Now the question is, what's the point of learning this? If I just equate it to half Li square, you will get the value of self-inductance. The value of self-inductance would be mu naught N square AL. Then what exactly is this N? N is number of turns per unit length. N would be number of turns per unit length. This is another way to find the formula for self-inductance in a solenoid. Remember these two. This one, energy stored in a not energy stored in a capacitor. These are the byproducts of this. These two are the most important thing. If you not write this in your notes also. Now, what if we have both electric field and magnetic field? Now, the question is, where do we have both electric field and magnetic field? We can get both electric field and magnetic field in a electromagnetic wave. Suppose if we consider an electromagnetic wave, then the energy stored would be half, I will assume vacuum right now, so half epsilon naught into E square plus half B square by 2 mu naught. Because an electromagnetic wave contains both magnetic field and electric field. And the speciality is that in an electromagnetic wave, the energy stored, this is energy stored in electric field, this is energy stored in magnetic field, both would be equal. So the net energy per unit volume would be half epsilon naught E square plus, in place of this also again you can write half epsilon naught E square only, because both would be equal. So you can write this as epsilon naught E square, or in place of this, if I write half B square by mu naught, you will get B square by mu naught. This is what we will get in a electromagnetic field, but the only difference is that the energy per unit volume is a fluctuating one. Why? Because E itself would be some E naught sine omega t or cos omega t. That means E will be like a variable. Since E is a variable, what we will do is we'll find the average value. So if you want average energy per unit volume, you have to do average of epsilon naught E square, because total energy is epsilon naught E square. So you'll get epsilon naught O square average of E square, which is nothing but RMS value. So you will get it as E naught square by 2, because E RMS would be E naught by root 2. So you have to just substitute that here. You will get E naught by root 2. So be very careful when you write the energy per unit volume or average energy per unit volume. And if you substitute everything carefully, we'll get the answer. So I'll again repeat this concept, because this is the only further extension where students get confused. So if you want energy per unit volume of an electromagnetic wave, energy per unit volume of electromagnetic wave, we get energy by volume, that is small u, would be equal to half epsilon naught E square plus B square by 2 mu naught. Remember, E and B are expressions. That means if E is proportional to sine omega t, B could be proportional to some cos omega t or something like that. So these are expressions basically, and these two would be equal. Since these two would always be equal, you will get the answer as epsilon naught E square or B square by 2 mu naught. But if you want average value of this, average value would become E naught. Now remember, in place of E, I will be writing E naught by root 2 whole square. So it will actually become half epsilon naught E square. Similarly, in place of B, I will be writing B naught by root 2. So you will get, this won't be there. You will get half B naught square by mu naught. Remember, try to understand the difference between what is E naught and what is E. Don't get confused between E naught and E. E naught is the maximum amplitude. E is the expression for that. I hope this is clear to you. We get the exact similar concept in simple harmonic motion also. In SHM, the formula for kinetic energy is half mv square, but V itself is proportional to cos omega t. So I can write V naught into cos omega t whole square. So you'll get half m V naught square cos square omega t. If you want average kinetic energy for this, the average kinetic energy would be half m V naught by root 2 whole square. So technically the average kinetic energy is actually 1 by 4 m V naught square. This is a very lengthy explanation for a single problem, but this explains everything that are related to it, and lot of like similar questions also we can answer based on this. That's why I took a lot of time to explain this. Just to go through it slowly and observe the thing slowly. This is a very important concept. We'll go for next one. In the circuit shown, the current through the 4 ohm resistor is 1 ampere. When the points P and M are connected to a DC voltage source, okay, the potential difference between the points M and N is the potential difference between the points M and N. Let us solve this. There is a very interesting way to solve the problem. The author is telling the current going through this is 1 ampere. The current going through this is 1 ampere. And if you observe it, this entire thing and this entire thing are in parallel. This entire thing and this entire thing is in parallel. These two together are not together. Like if I call this A, B, C, D, and E, F. So AB is parallel to CD, CD is parallel to EF. EF means this entire thing comes under EF. That means if all the parallel, I can directly tell that the voltage across AB must be equal to voltage across CD, must be equal to voltage across EF. Now let us find what is the voltage across AB. The voltage across AB is 4 ohm into current 1 ampere is going, so it will be equal to 4 volt. So the voltage across AB is 4 volt. We got this. That means the voltage across EF also must be equal to 4 volt only. Once we understood that, we can redraw this entire diagram. Like only consider the EF part. If you consider the EF part, 0.5 and 0.5, since they are in parallel, it will become 0.25. 0.5 and 0. And we have here 1 ohm. I'm only talking about EF. And we know the voltage across EF would be also equals to 4 volt. We already know what is R effective across EF. The R effective across EF is 1.25 ohm. Then based on this, the current across this would be 4 by 1.25. So 4 by 1.25 means 125 into 100 I can write. So it would be 4 into 4 by 5. So it would become 3.2 ampere. That means what is the current flowing through this? The current flowing through this would be 3.2 ampere. Now let us look at the full picture. If the current flowing through this is 3.2 ampere, total current is 3.2 ampere. Here 1.6 amperes would go. Here 1.6 amperes would go. And that would again mix and we'll get 3.2 ampere. We want potential difference across M and N because the author is asking what's the potential difference between M and N. So if I go, since current is traveling in this direction, so Vn minus Vm, if I go for the potential difference across M and N, we can see current I into R. You have to just travel from N to M. The only thing that is available is resistor. So this is 3.2 and 1. So basically you will get the answer as 3.2 volt. So I hope the methodology is very clear to you. First, the key concept in solving the problem is if the things are in parallel, all of them would have the same voltage. That's the first thing that you have to know. Once you identify that all of them got the same voltage, first you found what is the voltage across AB. The voltage across AB is 4 volt. If the voltage across AB is 4 volt, the voltage across EF also should be 4 volt only. So I've used that concept to get it. Even though it is not asked, if somebody asks you what's the current flowing through this, if you want current flowing through this, we will write VCDF by 3. VCDF would be 4 by 3 amperes. Even though they are not asking it, but here it would be 4 by 3 amperes. I hope this entire concept is pretty clear to you, how we are supposed to solve the problem and all that. There is one more. Let us assume that you don't like finding the current only. There is something called voltage distribution by which you can find what will be the voltage across this point. That I leave it to you. We'll go for next one. Okay, the question says the work function of a surface of a photosensitive material is 6.2 electron volt. The wavelength of the incident radiation for which the stopping potential is 5 volt lies in. So basically he is telling the stopping potential is 5 volt and work function is 6.2 electron volt. Let us find what is the energy incident. So energy incident, that means photon energy is equals to work function plus K maximum. This K maximum can again be written as work function plus E into V stopping potential. Stopping potential. So the work function is given as 6.2 electron volt plus E into the stopping potential is given as 5 volt. So basically we get 6.2 EV plus 5 EV So we get 11.2 electron volt. So the incident photon has an energy of 11.2 electron volt. We need to find its wavelength. To find the wavelength, we have to use a very important formula that you have to remember it also. That is 1 to 400 electron volt angstrom divided by 11.2 electron volt. This is the formula to get the value in angstroms. We can do it in nanometers also. 1240 electron volt nanometer divided by 11.2 EV. So if I cancel this EV and DV, we basically end up getting 1240 divided by 11.2 nanometers. So we can clearly see this would be like almost greater than 100, like slightly greater than 100 nanometers. So since it is slightly greater than 100 nanometers, we know our visible spectrum generally we consider it from 380 to like 700 plus nanometer. Then lesser than visible spectrum means basically if it is 100 nanometer, like this is close to some 110 or something like that, we can clearly see 100. If you multiply 1120, so slightly you can go for like slightly greater than 100, some 105. I'm not exactly solving it. So this will fall under UV spectrum. So the correct answer for this would be UV spectrum. But anyway, like exactly solve the value of 12240 divided by 11.2, you will get like some 110. But you no need to solve this, you no need to divide it. They can tell that the answer would be slightly greater than 100, then it will fall under UV spectrum. We'll go for next one. But the key formula in this is this 1 to 400 electron volt angstrom divided by 11 point electron volts. This is the key formula in solving this. We'll go for next one. A galvanometer of resistance 50 ohm is connected to a battery 3 volt along with a resistance 2950 ohm in series. A full-scale deflection of 30 divisions is obtained in the galvanometer. In order to reduce the deflections to 20 divisions, the resistance in series should be. So a galvanometer is converted into an voltmeter here. So we have taken a galvanometer and we have connected an external resistance of 2950 ohm. The galvanometer itself is 50 ohm. You have connected it. And you have connected it like, because he has given when connected to a battery of 3 volt. So right now you have connected it to a battery of 3 volt and we get a current here. So we can write I into R, like total R effect would be 50 plus 2950. So 3000 is equals to 3 ohm. Then this, rather than giving you the value of I, the author is telling the full scale deflection of 30 divisions. If number of divisions are given, so in place of I, we can write some constant into divisions into 3000 equals to 3 volt. So based on this, so K into 30 into 3000 equal to 3. So we'll keep it as the equation 1. Now the author is telling, in order to reduce this deflection to 20 divisions, I want the number of deflection to be reduced to 20 divisions. Then the author is asking what should be the resistance that must be connected in series. Suppose in the same thing, now we are connecting an unknown resistance. We don't know this resistance. I'll call this X. But this time the current should be K into 20 divisions. There is no change in the battery. The battery is still 3 volt only. So in this case, we can write K into 20. That is I into R effective. R effective would be 50 plus X. It is still equal to 3 volt. This is equation 2. Just divide both of them or equate both of them. If I equate both of them, since 3 are same, I will get K into 30 into 3000 would be equals to K into 20 into 50 plus X. If you observe it, how I solved the problem, I solved this problem with a simple fact that V equals to IR. Now you cancel these two. So 50 plus X would be equals to 30 by 20 into 3000. 30 by 20 is 1.5. 1.5 into 3000 would be 4500. So the value of X would be 4450 ohm. So the correct answer for this would be 4450 ohm, which would be my option B. Okay, the question says the water falls from a height of 60 meter at a rate of 15 kg per second to operate a turbine. The loss is due to frictional force is 10% of the energy. How much power is generated by the turbine? So basically, water is falling from a height of 60 meter. So water is falling from a height of 60 meter. So here we'll have a turbine, and this water would hit these turbine blades. So what happens is that the water would fall from a height and it will hit the turbine blades. Because of this, these turbine blades would keep on rotating. So technically, what is happening is that whatever is the potential energy of the water that is present here, if let us say water is at a height h, the potential energy of the water would eventually get converted into kinetic energy. Then we can write power equals to energy by time. So energy would be mgh divided by time. But the author is telling there is a 10% energy loss due to friction, because when the water is traveling and due to collision and all those things, some 10% energy is lost. So then basically we can write power obtained would be, if 10% is lost, we only obtain 90% of this. So 90% of mgh divided by time t. So simply 90 by 100. The mass is given as 15 kg. Time is given as 1 second because it is given 50 kg per second. G is given as 10. And height value is 60 meter. So if I do that, these two zeros would cancel each other. So 15 6 are 90 into 90. So I'll get this as 8100 watt. 8100 watt is 8.1 kilowatt. Actually, this K has to be small. So 8.1 kilowatt. This will be the answer for this. So it would be my option C. We'll go for next one. In an AC circuit, the EMF E and the current I at any instant are given by E equals to E naught sine omega t, E equals to I naught sine omega t minus phi. The average power in the circuit over one cycle of AC is. Suppose if you want average power, the formula is VRMS. So the question says, in an AC circuit, the EMF E and the current I at any instant are given by E equals to E naught sine omega t, E equals to I naught sine omega t minus phi. The average power in the circuit over one cycle of AC is. So average power is VRMS into IRMS into cos phi. But here, the phi that we write in the formula and the phi that is given in the question are different. So to avoid confusion, I will write cos delta or something like that. But the thing is, this phi that is given in the question is actually different from the phi that we use in our formulas. So I will write like cos some like this, where this is the phase difference between voltage and current. So technically speaking, in our syllabus, in NCRT, if you go and see the NCRT, he has given this delta, like both are deltas only, are basically, it is the phase by which current leads voltage. Means, what do you mean by which current leads voltage? Means first you have to find phase of the current and you have to subtract with the phase of the voltage. From this question, we can clearly see the I naught sine omega t minus phi is given. So the phase of current would be omega t minus phi. Minus, what is the phase of voltage? It would be omega t. So minus omega t. So you are actually getting this as minus delta. So delta would be equals to minus delta. Just substitute it. Average power equals to VRMS into IRMS into cos of minus phi. Anyway, that itself is again cos phi only. So VRMS into IRMS into cos phi, because cos minus theta would be cos theta only. So based on that logic, and one more, he wants the answer not in terms of RMS, he wants in terms of maximum values. So VRMS is V naught by root 2. So I can write E naught by root 2 into IRMS is I naught by root 2 into cos phi. So you get it as E naught I naught by 2 into cos phi. Again, I will repeat the value of in the average power formula that is given its definition is very different. This basically talks about how much current is leading. Current is leading compared to the voltage. And based on that only, we'll actually get the formula. Like based on impedance expression, impedance, we'll get the phase of impedance. If alpha is the phase of impedance, we'll get cos alpha equal to XL minus XC by Z. But whereas cos delta delta, technically this is given as cos phi in NCRT. Remember, don't be confused with the phi given in the question and the phi that we actually use in NCRT. This is XC minus XL by Z. This phi that is given in NCRT is how much current leads voltage in phase. Okay, that's it. So this is a very important formula. Once you get this formula, if you get phi as 90 degree, that we can tell that current leads the voltage by 90 degree in phase. I hope this entire thing is clear to you. So we'll get the answer as option A. Even if you don't know all these late letters, you don't know all this, you know only that VRMS into IRMS into cos phi. Even if you take plus phi minus phi, since it doesn't matter, so E naught by root 2, I naught by root 2 into cos phi. This is what we'll get here. We'll go for next one. If Q, E, and W denote respectively the heat added, change in internal energy, and work done in a closed cyclic process, then see, it's telling closed cyclic process. So first you have to understand what happens in a cyclic process. In a cyclic process, the body would start from one point and it will go in another route, and again it will reach one point, and again it will come back to the original point. That means starting point would be equal to ending point. Starting point is equals to final point. Since starting point is equals to final point, the change in internal energy would be zero. Remember this, the change in internal energy would be zero. So directly we can tell change in internal energy, which is represented by E here, is zero. So directly the value of E would be zero. Whether heat added is zero or not, like we don't know, depending upon whether it's an adiabatic or some other process. But we can directly tell as long as it's a cyclic process, the change in internal energy is zero. If change in internal energy is zero, we can write the heat would be equals to work done. The heat would be equal to work done. That's how we get the heat added and all those things. Right now, I'll not tell whether it is a positive work done or negative work done, because we can tell it based on clockwise or anti-clockwise. Right now, I don't want to get into that discussion. Just remember, the body is going from the same starting point and ending at the same final point. We can tell that the change in internal energy is zero and Q will be equals to double E. We'll go for next one. A long solenoid has a 500 turns. When current of 2 amperes is passed through it, the resulting magnetic flux linked with each turn of the solenoid is 4 into 10 power minus 3 Weber. The self-inductance of the solenoid is, so there is a long solenoid has a 500 turns, and when current of 2 amperes is passed through it, the resultant magnetic flux through each turn of the solenoid is 4 into 10 power minus 3, the self-inductance is. Suppose if you want to find self-inductance, you should know that the flux total through the solenoid will be equal to self-inductance and current flowing through the solenoid. The flux total would be, if you have n loops, so and each loop has a flux of phi, so n into flux of each circular turn, n into flux of each circular turn, flux through each circular turn is equals to L into I, because if you have n turns like this, then the value of n is given as 500. So 500 into flux through each one of them, flux through each one of them would be given as 4 into 10 power minus 3. So 4 into 10 power minus 3 is equals to L into I value is given as 2 amperes. So L value would be, so 500 into 2 into 10 power minus 3. So it would be equal to 1 Henry. So the answer for this would be 1 Henry. So to explain, you did all this, but if you notice the options are unique, remember this. When the options are unique, you no need to bother about 10 powers. So if I was solving the problem, I know 5, I will directly write 5 into 4 is equals to L is equals to 10, which is equals to 1, and I would have marked it. If you understood what I have done, that means you understood how to solve the problems in a NEET examination. You can ignore all the 10 powers while solving the problems in a NEET examination. You no need to write the step by step 10 powers 500 into 4 into 10 power minus 3. Well, substitute, you can simply write 5 into 4. Then what about 100 into 10 power minus 3 means these are called 10 powers which we can ignore. Why we can ignore is that when the options are unique, we can ignore all the 10 powers. So we will get L equals to 20 by 2. You will get it as 10, which is nothing but 1. Because you ignored all the 10 powers. That's how we solve these problems. So practice it. You can ignore 10 powers while solving the problems. Especially when difficult questions are there, this logic would be very useful. We'll go for next one. An electric kettle takes 4 ampere current at 220 volt. How much time will it take to boil 1 kg of water from temperature 20 degrees centigrade, the temperature of 100 degrees centigrade? First thing you should understand, what is the meaning of time to boil? Time to boil does not mean that the water would reach the liquid stage and from liquid stage to vapor stage. That is not like time to boil means like time required to convert water into 100 degrees centigrade. That's it. We are not concerned about further conversion. We no need to further convert that water at 100 degrees centigrade into steam at 100 degrees centigrade. If that must be asked, rather than asking to boil 1 kg of water, he will use another word. Like let us say right now we have to stop the problem when water reaches 100 degrees centigrade. But what if we need further conversion? We want the water to further convert from 100 degrees centigrade to steam at 100 degrees centigrade. The term that must be used here is boil away. If the boil away is given, then apart from this, we will also take like steam at 100 degrees centigrade. We'll add this also. But right now, since that boil away word is not given, we can understand time to boil is simply time required for the water to reach 100 degrees centigrade. Now, we know Q equal to, when you heat it through a resistor, I square RT. T is the time, which must be equal to ms delta T. Now, let us substitute everything carefully. So, the time required would become ms delta T by I square R. So let us substitute everything carefully and we'll get our answer. So the first one is I square would be 6. M mass is given as 1 kg. So 1, specific heat is 4200 into delta T value is, I generally do it in another way. I personally like to do everything in CGS. That is grams calories, because specific heat of water is 1. It is very easy. So I will write 1 kg of water as 1000 grams. Specific heat is 1 calorie per gram. Delta T value is 100 minus 20, so it would be 80. But in this way, you will get the answer in calories. Since you get the answer in calories, you have to convert into joule by multiplying 4.2 divided by this I square value would be 4 square, that is 4 into 4 into the resistance value is given as, okay, he has given the voltage, so we don't need that one. We can just use V into I here. Because I into R would be V. So V into I, if I use 220 into the I value is given as 4. So 4 table 20 times, these two I can cancel it out. So 2 table 11 times. So you basically get time equals to 42 into 100 divided by 11. But we want the time in minutes. Since we want the time in minutes, this we got it in seconds. So divide everything by 60. So 100 by 11 into 60 minutes. So these two also if I get cancelled, 7 6 are 42, you basically get 70 by 11. So I'll get 6 point something. Since we get 6 point something, the only answer would be option 3. We'll go for next one. But the key concept is, what is the meaning of boiling water? Like taking the water to boiling means it is not like converting it into steam. It is just reaching the boiling point. If the word boil away is given, boil away 1 kg of water is given, then we have to not only convert it into water, we have to convert it into steam also. I hope this is clear to you. We'll go for next one. A boy is trying to start a fire by focusing sunlight on a piece of paper using equiconvex lens of focal length 10 centimeter. The diameter of the sun is 1.39 into 10 power 9 meter, and its mean distance from the earth is 1.5 into 10 power 9. The diameter of the sun's image is. See, we are using a convex lens to focus on things. We can see that the sun is very, very far away. Like the sun is at 1.5 into 10 power 11 meters. We can almost think like the object is at infinity only. If the object is at infinity, we know where will the image would be formed. The image would be formed at the focus. So when u is approximately infinity, then the image would be forming at the focal length. And we know I am only taking magnitude of magnification now, so which would be equal to v by u, which would be equal to height of image by height of object. Height of image by height of object can be written as diameter of the image by diameter of the object. So the v value that we got is focal length. U value, you might wonder why can't we write it as infinity? Rather than, right now we need the exact value of the image. Since we need the exact value of the image, we will take the value that is given in the question rather than infinity. We'll take the value that is given in the question, 1.5 into 10 power 11. So focal length value given in the question as 10 centimeter. So 10 into 10 power minus 2. U value is 1.5 into 10 power 11. Diameter of the image by diameter of the object would be 1.39 into 10 power 9. So from this diameter of the, how do we get the diameter of the image? We almost get like a small dot. You must have done this experiment. So 10 power minus 1 into 1.39 into 10 power 9 divided by 1.5 into 10 power 11. So this I will write 1.39 divided by 1.5 into this will be 10 power minus 12. So you'll get 10 power minus 3. So this would be roughly 0.9 into 10 power minus 3 because it can't be 1. 0.9, so 9 into 10 power minus 4. So something into 10 power minus 4 we need. So which would be my option C. So the key concept is, since u is almost infinity, then v will be approximately equal to focus. So v will be approximately equal to focus. Then we will use those two to find the diameter of the image. That's the key concept here. We'll go for next one. A closed loop PQRS carrying a current is placed in a uniform magnetic field. If the magnetic forces on the segment PS, SR, and RQ are F1, F2, F3 respectively, are in the plane of the paper and along the direction shown. The force on the segment QP is. Now remember, if you have a loop placed in a uniform magnetic field, this is very important. If you have a current carrying loop placed in uniform magnetic field, the word uniform is very important. So if you place it in a uniform magnetic field, the net value, the BF, the net force acting on the loop must be equal to 0. That means the force due to PS plus force due to SR plus force due to RQ plus force due to PQ must be equal to 0. Yeah, there is a PQ or QP, it must be equal to 0. So force due to PS is minus F1. I think this should be F1. It is not printed properly. It should be F1. So minus F1 into, it is pointing to the left. I'll write I cap for convenience. Plus force due to SR would be F2 into minus J cap. Plus force due to R3 would be F3 into I cap. Plus force due to PQ. 0. So from this force due to PQ would be F1 minus F3. When I took it to the other side, I cap minus plus F2 J cap. Then what is the magnitude of the force acting on the PQ part? It would be root of F1 minus F3 whole square plus F2 square. This should be the net value of the magnitude. F1 minus F3, whether you say F1 minus F3 whole square or F3 minus F1 whole square, it doesn't matter. Both are same things only. So the answer would be option D for this. But technically, to explain, you have solved like this many steps and all those things, or else immediately what I will do is, if I'm solving as a student, since the net force is 0, this should be F3 minus F1. This is the net force acting. Here must be, I must get F2 here. So simply root of F3 minus F1 whole square plus F2 square. Magnitude since should be both be equal. I would directly do root of F3 minus F1 whole square plus F2 square. That's how I would have done it in one step. We'll go for next one. A cell can be balanced against 110 centimeters and 100 centimeters of potentiometer wire respectively, with and without being short circuited through a resistance of 10 ohm. Its internal resistance is. See, right now, this concept is not required for us. Like potentiometer wire concept is not there. So, like it is recommended for you to not learn this. So, I will not explain this here. If at all this is added, if potentiometer is ever added in the future, so right now this is in 2026. If this is ever added in the future, I'll just make a separate recording of all the potentiometer questions. We'll go for next one. Two periodic waves of intensities I1 and I2 pass through a region at the same time in the same direction. The sum of maximum and minimum intensity is. So we know in intensity, the formula is I maximum equals to root of I1 plus root I2 whole square. Then minimum intensity formula would be root I1 minus root I2 whole square. Now the author is asking the sum of maximum and minimum intensities. So he wants you to add the maximum possible intensities and minimum possible intensities. It is like adding a plus b whole square plus a minus b whole square. So root I1 minus root I2 whole square. So you know a square plus b. So if you already know it, it will be 2 of a square plus b square. If you add a plus b whole square plus a minus b whole square. But for our convenience, for your convenience, I'll do it. So I'll get I1 a square plus b square plus 2a1 a2. This would be a square plus b square minus 2a1 a2. Then these two things would cancel each other and we get the answer as 2 times I1 plus I2, which would be my option B. 2 times I1 I2, which would be my option B. We'll go for next one. A wire of certain material is stretched slowly by 10%. Its new resistance and specific resistance become respectively. Let me tell you, specific resistance doesn't change by stretching. So specific resistance remains same. And if you stretch a wire, its resistance would change. So one of them must be remain same, another one must change. So the only possible option is this one. Specific resistance must be same. So these two options I can eliminate, and one of them must change. And if you stretch it, its resistance would change. I would mark this and go. I will not like sit and solve it, but I'll explain you the concept for this. Generally, the formula for resistance is resistance equals to rho L by A. This is a normal formula for a resistance in a wire or something like that. But if you stretch it, when you stretch something, what happens is that its area would decrease and the length would increase. Its area would decrease and its length would actually increase. It is like you stretch a dough. If you take a chapati dough and stretch it, you'll notice that its area decreases, area of cross section decreases, but its length would keep on increasing. So in these cases, we can tell that initial area into initial length must be equal to final area is equals to final length, and which must be say that their volume is not changing. So in these situations, the volume is not changing. Their area and lengths are changing, but the volume is not changing. So whenever in the questions, the word melting or recast or stretching, these kind of words are used. We won't use R equals to rho L by A formula. We'll bring volume into the picture. So what we'll do is, this is the traditional formula rho L by A. We will replace the length with volume. If I replace the length with volume, then we know L into A is equals to volume. Then L is nothing but volume by A. So in place of length, I will write volume by A into 1 by A. So you basically get rho into volume by A square. The same logic, I can replace the area by volume. Then we'll get volume by length. So I'll get rho L square by volume. So the summary of this is, the normal formula for resistance is rho L by A. If stretching or melting is used, if stretching or melting is used, melting and recast. These kind of words are used. Then we'll replace the things with, we'll square one of them and we replace the other one with volume. We square one of them and replace the other one with volume. So these are the two formulas. Which one to use depends upon question to question. Like example, in this question, he has said that is stretched slowly by 10% means the length increased by 10%. So I have to use this formula. So we can write resistance proportional to L square. So final length is initial length plus 10% of the initial length increased by 10%. So 10% is 10 by 100 into L. So I'll get it as L plus 0.1 L. So it would be 1.1 L. So based on this, R2 by R1 is equals to L2 by L1 whole square. So L2 value is 1.1 L divided by L whole square. So you basically get R2 by R1 equals to 1.1 whole square. So that is 1.21. So R2 would be 1.21 times the R1. So the correct answer for this would be option D. We'll go for next one. A roller coaster is designed such that the riders experience weightlessness as they go around the top of a hill whose radius of curvature is 20 meters. The speed of the car at the top of the hill is between. The speed of the car at the top of the hill is between. So basically right now, in roller coaster, we are going on top of the hill like this, like it is going like this. So this is where the roller coaster is. And it is experiencing weightlessness. What is the meaning of weightlessness? This is important. So weightlessness, it implies that the normal reaction is zero. That's what weightlessness means. It means the normal reaction is zero. So let us draw free body diagram. We have mg here. We have normal reaction here. And the acceleration would always be towards the center of the circle. So mg minus n is equals to m into AC. So in weightlessness, n is 0. So mg is equals to m into v square by r in circular motion. So v must be equals to root of rg. So v is greater than this. If v value is equals to r, like rg, we will experience weightlessness. Weightlessness means it will lose contact with the ground. Normal reaction would become 0. So what is the r value given here? The r value is given as 20 into g value is 9.81. So if I do 9.81 into 2, we are getting root 19.62. We know 196, like if I do, okay, 196.2, sorry. See, if you do 196, it is 14. 220, 15 square is 225. So 15 square is 225. 196 is 14. My answer is between 14 and 15 only. So the correct answer should be 14 and 15. Some people have asked why it can't be 13 and 14. Like example, generally we take either 9. Sir, what if I exactly take 9.8? I'm getting 196. So why can't it be 14 and we can say this one? You should understand that if you are taking the exact value, why take 9.8? The exact value should be 9.81, number one. But in general, it is not necessary that G has to be 9.81. We take it as 10 also sometimes. So root 200 also is between 14 square and 15 square only. 15 square is 225, 14 square is 196. So we can say whatever conditions we take, the answer we are getting it between 14 and 15. But if it is latest NEET examination, he will actually mention you what should be the value of G that should be taken. So don't worry. We'll go for the next one. A shell of mass 200 grams is ejected from a gun of mass 4 kg by an explosion that generates 1.05 kilojoule of energy. The initial velocity of the shell is, he's asking what's the initial velocity of the shell. So simply if we say energy released due to the explosion of the cell, so energy released is simply equal to final kinetic energy. What is kinetic energy? Kinetic energy due to the shell plus kinetic energy due to the gun value. So the kinetic energy of the shell, I will write half m into v shell square plus half gun capital M into v gun square. And we know in gun bullet model, this is called as gun bullet model. There is a very important ratio that you should know. The ratio of their kinetic energies. So the ratio of the kinetic energies like K of shell divided by K of gun would be inversely proportional to the masses. Would be inversely proportional to the masses. Why? Because their momentum would be equal. I will not discuss the concept here in detail. So it will be inversely proportional to their masses, but it will be directly proportional to their velocities. That means it will be equal to velocity of the shell by velocity of the gun. I think not V square. Like example, kinetic energy is half mv square equals to p square by 2m is equals to half pv. If you take this formula, you'll get kinetic energy proportional to v square. If you take this formula, kinetic energy is proportional to v. Now the question is, which formula should I take? Should I tell kinetic proportional to v square based on this formula, or kinetic energy is proportional to v based on this formula? Remember, the proportionality should only be told when all the other terms are constants. That means both are wrong. If mass is constant, in the question, if they given, if mass is constant, in that situation we can tell kinetic energy is proportional to v square. Similarly, if momentum is constant, which happens in gun bullet model, we can tell that kinetic energy is proportional to v. So remember, it's not like by looking at the formula you can tell kinetic energy is proportional to v square and kinetic energy is proportional to v. Based on the condition, underlying condition, we can use the word proportionality. Keep that in mind. Now, based on that logic, so we get, if I get K of shell common, we'll get 1 plus K of gun divided by K of shell. So which we can write this as energy released. Now the question is, why are we getting the K of shell as common? Because the other is asking us to find the initial velocity of the shell. So if I know kinetic energy of the shell, I can find the initial velocity of the shell. So kinetic energy of the shell into 1 plus kinetic energy of the gun by kinetic energy of this shell would be mass of shell divided by mass of gun. So I'll take it to the next page and solve it. So I hope till here the concept is clear to you. So if I take it to the next page, energy is given as 1.05 kilojoule. Kilojoule equals to kinetic energy of the shell. Mass of the shell is given as 200 grams. 200 grams means 200 by 1000 kgs into mass of the gun is given as 4 kg. These numbers are given intentionally, so it will be 50. So this 1.05 kilo means 10 power 3 equals to kinetic energy of the shell into, you can notice it, this is also again we are getting it as 0.5 only. So 1.05 on the left side and right side would get cancelled. So kinetic energy of the shell, you got it as 1000 joule. We know kinetic energy of the shell is half mv square, so mass is 1/5 half m into velocity of the shell square is equals to 1000 joule. So velocity of the shell equals to root of 10 power 4. So it should be equal to 100 meter per second. So the key concept is learning this formula, getting this formula from this one, and knowing this concept is very important. If you don't know it, write it in your notes. This is a very important relation in gun bullet model. Once you have written this, we can write energy released equals to. So we can use 3 versions of energy released. You can write energy released equals to kinetic energy of the shell plus kinetic energy of the gun. If you get kinetic energy of the shell common, 1 plus kinetic energy of the gun by kinetic energy of the shell, you will get, which would be equal to 1 plus mass of shell by mass of gun. If you observe it, if shell is outside, the mass of the shell is also inside. Similarly, if you get kinetic energy of the gun as common, you'll get 1 plus mass of gun by mass of shell. So these are the key formulas that we use in solving this problem. So the correct answer for this would be 100 meter per second. So this will be the answer for this. We'll go for next one. A thin conducting ring of radius r given a charge plus q. The electric field at the center O of the ring due to the charge on the part AKB of the ring is E. The electric field at the center due to the charge part ACDB of the ring is. So let us go for it. First, you should know what is the electric field at the center of the ring. So electric field at the center of the ring is 0. That means the electric field due to AKB plus electric field due to ACDB must be zero. The electric field due to this part and the electric field due to the entire remaining part, the electric field due to the entire remaining part together must be equal to zero. So based on this, we can simply write the electric field at ACDB is exactly opposite to the electric field due to AKB. Since it is exactly opposite to electric field AKB, first we should see what's the direction of electric field due to AKB. Since this is a positive charge given, the electric field at O would be away from the body like this. It would be in this direction. It would be in KO direction. Now, in which direction the AC dB must apply the force? The AC dB must apply the force in this direction with exactly equal magnitude. So it is simply E only, but along OK direction. Means it must apply opposite to whatever this AKB part is applying. So the answer should be E along OK. This will be the answer for this. We'll go for next one. A PN junction, a PN photodiode is made of a material with a band gap of 2 electron volts. It is made of a material with a band gap of 2 electron volts. The minimum frequency of radiation that can be absorbed by the material is. So if you need, you just see how the photodiode functions and all that. There is a detailed recording on that. But for now, he has given a band gap of, so energy as 2.0 electron volt. Now let us find what is the lambda of the incident radiation. So the lambda required would be equals to 1 to 400 electron volt angstrom divided by 2 electron volt. So EV would get cancelled. So we will get 1 to 400 into 10 power minus 10 meters. Now from this we can find C equal to F lambda. So we can write F minimum will be equal to C by lambda. So C value is 3 into 10 power 8 divided by 1 to 4 into 10 power minus 8. So I'll get 3 by 124 into 10 power 16. So 3 table 4 times, approximately if I take 41. So 1 by 40 into 10 power 16. I'm doing it approximately. So 1 by 41 is 0.25 into 10 power 15. So 0.25 into 10 power 15 would be 0.25 into 10 power 15 we got. So we can write 2 into 10 power 14. So we get this value as, I think we have done a small mistake here. Like I did not divide this with 2. So that's why I'm not getting any answer. So it will become divide by 2. So it would become 6 to 100 into 10 power minus 10 meters. So it would be 62 into 10 power minus 8. I'll just change this. So 62 into 10 power minus 8. So I can get this as 1 by 20 into 10 power 16. So 1 by 2 into 10 power 15. So 5 into 10 power 14 hertz. So all these are approximate only. So we'll get the answer as 5 into 10 power 14 hertz, which would be my option D. You can do another way also. You can use E equal to H nu, but I don't recommend it. Nu value would be equal to E by H. So E value in electron volts is given to you. So he has given the E value as 2 electron volts. So 2 into 1.6 into 10 power minus 19 by H value is 6.6 into 10 power minus 34. So you solve this and you will get the value. So it is like I'll take approximately 4, 16 fours are 64, 0.5 into 10 power 34 minus 19. So whenever 34 minus 19 is given, I generally do it like 35 minus 20. I'll add 1 and add 1, so you'll get 15. So 0.5 into 10 power 15, you'll get 5 into 10 power 14, which would be my option D. We'll go for next one. The electric potential at a point in free space due to a charge q coulomb is q into 10 power 11 volts. The electric field at that point is. So the electric potential at a point in a free space is given. So electric potential due to a charge q at a point in free space. Let us assume that point is at a distance x in a free space is given as q into 10 power 11 volts. Okay. So if I cancel these two values, so I'll get the value of x as k by 10 power 11. K we know is 1 by 4 epsilon naught. We'll substitute that later. Okay. Now he want the electric field at that point is, if you want electric field would be kq by x square. So I can write kq by x value we just obtained from the previous expression, k square by 10 power 22. So I'll get q into 10 power 22 divided by 1k would cancel the other k. So you know k is 1 by 4 epsilon naught. 1 by k would be 4 pi epsilon naught q into 10 power 22 volt per meter. So volt per meter we'll get. So we'll get the answer as 4 pi epsilon naught q into 10 power 22, option C. So the key concept is don't overthink in these problems. Just write the formulas of both of them. And if you observe what is the unknown from these formulas, that you will identify that x is the unknown in the formula and you will be able to solve it. Why some people get confused is they will start this problem is E equal to like V equal to Ex, and they will try to like get the answer by substituting things here, and they will keep on getting confused. Where is the x value? We did not get the value of x and all those things. I hope this is clear to you. We'll go for next one. If the error in measurement of radius of sphere is 2%, the error in the determination of volume of the sphere is. So first we should know what's the formula for volume of a sphere. It is 4 by 3 pi r cube. So if you want error, the formula is delta V by V is equals to, you can ignore all the constants. Whatever is the power of this, only you will take it. The power of R is 3, so 3 into delta R by R. The other is telling error in determination of this R is 2%. So the total error would be equal to 6%, which would be my option D. 3 2s are 6%. So the error in determining the volume would be 6%. Remember, whenever you tell the errors, you can ignore all the constants and you can do it. Like example, if kinetic energy is half m into v square, you can ignore this half. Then error in kinetic energy would be, this is how you represent the error, is delta m by m, since we have multiplication, plus the power, this is power 1, so we are at 1 delta m by m plus 2 delta v by v. Similarly, one more that is very famous in error is time period equals to 2 pi root L by G. So I can write 2 pi L power 1 by 2 G power minus half. So if delta T by T would become 2 pi is a constant, you can ignore it, half delta L by L. In error, there is nothing like negative plus half delta G by G. In error, there is no negative positive, everything would be positive only. We'll go for next one. A particle of mass m is projected with velocity v, making an angle 45 degree with the horizontal. When the particle lands on the level ground, the magnitude of the change in momentum would be. So we have a particle that you have projected with velocity v and at an angle theta. We know when it lands in projectile motion, it will exactly hit it in that way with the same angle theta. If I take this entire thing and I bring it here, isn't it similar to ball hitting the wall model? This is similar to a ball hitting the wall model. It hits with V and it bounces back with V. So since it is similar to ball hitting the wall model, so you should know that the change in momentum would be equals to 2 mv sine theta, where theta is the angle with the wall. Then you can directly do it in one step, 2 mv into sine 45 degrees. Sine 45 degrees is 1 by root 2. So 2 mv into 1 by root 2. So you'll get the answer is root 2 mv. So the correct answer for this would be root 2 mv, which would be option E. But let us say you did not realize that this is similar to ball hitting the wall model. You can do step by step also. This is V. I can resolve this into V cos theta and V sin theta. Here also I can resolve this into V cos theta and V sin theta. So when I subtract them, both are in the same direction. When I subtract them, these two would get cancelled out. So I'll get minus V sin theta because it is pointing downward, minus of plus V sin theta, which is pointing upward. I'm doing it vectorially. So I'll write j cap for convenience. I'll take down as j cap. So this is also j cap only. So I'll get minus 2mv sine theta or 2v sine theta into j cap. This is the change in velocity. Then if I want change in momentum, it would be minus 2mv sine theta into j cap, and simply the magnitude of change in momentum would be 2mv sine theta. Remember, this is similar to ball hitting the wall model. That's the right way to do it rather than doing all these step-by-step things. We'll go for next one. Three forces acting on a body as shown in the figure. To have the resultant force only along the y direction, the magnitude of the additional force required is, I want the resultant only along the y direction. First, let us solve this. We have 4 in this direction, 3 in this direction, exactly equal and opposite. I can remove this and we can write 4 minus 2 Newton because both are opposite. So the answer would be 2 Newton. So I can redraw this entire thing as, we have if 2 Newton here, we have a 1 Newton here because this 4 and 2 fought and we got 2 Newton and we have 1 Newton and this is given as 30 degree. So if I resolve this 2 Newton into components, I will get 2 cos 30, 2 sin 30. So you'll get here 2 cos 30 degree. Here you will get 2 sin 30 degree. Similarly, this is given as 60 degree. I will resolve this 1 into component. So I'll get 1 cos 60, 1 sin 60. So you basically get 1 cos 60 degree and 1 sin 60 degree. If you notice it, these two would add each other, these two would opposite each other. So this would be 2 into 1 by 2, 1, 1 into 1 by 2, 1. So the net force in x direction is 1 by 2 because 1 minus 1 by 2, this is the net force. Net force in y direction is like no need to add that. I'll tell you some kind of like Fy will write it. The author is telling, I want the resultant force only along the y direction. Since we want the resultant force only along the y direction, that means I don't want any force in the x direction. What does this mean? If I want that the resultant force only along the y direction, that means resultant force along the x direction must be 0. For the resultant force along the x direction to be 0, that means the additional force that I required is 1 by 2 to the right. Because 1 is to the left, half is to the. So I hope this is clear to you. So when you have the net force half in the left direction, to counterbalance it, we need a net force half in the right direction. We'll go for the next one. A particle of mass m, charge q and kinetic energy t enters a transverse uniform magnetic field of induction b bar. After 3 seconds, the kinetic energy of the particle will be. So you have to understand one thing very clearly, that the magnetic field does not change kinetic energy, does not change kinetic energy. It only changes the direction of velocity, only changes direction of velocity. It doesn't change the magnitude of velocity, it only changes direction of velocity. Since it only changes direction of velocity and does not change kinetic energy, whether it is 3 seconds, 30 seconds, or 3000 seconds, the kinetic energy originally is t, while entering the finally also it will be t only. So this will be the answer for it. We'll go for the last one. A thin rod of length L and mass m is bent at its midpoint into 2 halves, so that the angle between them is 90 degree. The moment of inertia of the bent rod about an axis passing through the bending point and perpendicular to the plane defined by the 2 halves of the rod is. Now, generally, if you have a rod like this, and if you want moment of inertia about the center, we know that it will be ml square by 12. But what the author is asking, what happens if I bend it in this way? And now what will be the value of this? Let me tell you, now also the answer would be ml square by 12 only. It doesn't matter how you bend it. If you are trying to find it perpendicularly, if you are trying to find perpendicularly along the center of mass, it will always become ml square by 12. And I'll prove that. Let us assume this mass is m, this length is L, this mass is m, this length is L. What is the moment of inertia due to this rod? Right now, for this small section, this axis is like moment of inertia of a rod about the corner. So it will become ml square by 3. Because of this also at the corner, ml square by 3. So the I net value would become simply 2 ml square by 3. So 2 by 3, the mass of half of this would be m by 2. The length of half of it would be L by 2 whole square. So you will get ml square by 2 into 4 into 2 by 3. So 2 would get cancelled. You will get it as ml square by 12. As I already told you, it doesn't matter to what angle you bend. Whether, let us say, while you are writing, the answer is given as v, so that the angle becomes 60 degree or like 80 degree. Whatever angle it has take, you have bent it, the answer would be ml square by 12 only. Just remember that. So we're done with this paper. See you with the next one.